All right, in this video, we're going to be looking at section 2.6, which is solving quadratic inequalities, okay? And this can be a very challenging concept to grasp. So I want to start with an example right off the bat, and we're going to try to relate solving linear inequalities with quadratic inequalities, both algebraically and graphically, okay? So here you can see I have two functions, f of x and g of x. F of x is linear, g of x is quadratic, and I have their graphs over to the right, okay? And for both f of x and g of x, we're asked when are they greater than 0, okay? Now here's where you have to have a good understanding of notations, function notation. F of x is a notation that represents the y values of the function f. And g of x is a notation that represents the y values for the function g of x, right? So we want to know for what values of x are the y's of each of these functions greater than 0. So let's write that out, okay? What these inequalities are really asking us for are for what values of x are the y values of each function greater than 0, which means positive. Okay, so let's pretend for a moment we didn't have the equations for the two functions, and instead all we had were the graphs, okay? So graphically, when your y values are positive, that means your corresponding points would have to be above the x-axis, okay? So in the case of f of x being greater than 0, we would be focusing on this portion of the graph right here, the part of the line that is above the x-axis. And specifically, we want to know what are the x-coordinates of those points, okay? The x-coordinates would be anything larger than -4/3, okay? Which is kind of hard to reason out just by looking at the graph, but I'll show you here in a second how I knew it was exactly -4/3, okay? So we're talking about all of these x values right here. Those are the solutions to that inequality, okay? Now for the function g of x, when it's greater than 0, it's going to be the same thing. It's when is the parabola above the x-axis? We would be focusing on this portion of the curve as well as this portion, and specifically, what are the x values of those points, okay? They would be anything smaller than -3 or anything larger than 1. So I would say my solution to this inequality is x less than -3 or x greater than 1. Okay? All right, now let's bring the equations back into play for each function. All right, so solving f of x is greater than 0, you wouldn't really need the graph if you knew that f of x was equal to 3x plus 4, right? So what you could do is kind of substitute in for f of x what it's equal to, 3x plus 4, and say that's greater than 0. And then solving, that's how you end up with the x is greater than -4/3. So it's really easy to algebraically solve a linear inequality, okay? If we try the same approach for a quadratic, here's what's going to happen. I see this all the time from students. They're going to try to take the exact same approach as what we did in the linears. They're going to take x squared plus 2x minus 3, substitute that in for g of x, and then typically what happens is they try to factor. They end up with x plus 3, x minus 1 greater than 0. And then from here, they try to solve this the exact same way as if it were an equation. So they'll take x plus 3, and they'll try to make that greater than 0. And they'll also say x minus 1 is greater than 0. And they'll end up with x is greater than negative 3, as well as x is greater than 1. Now compare that with what we answered right here, okay? Those results are not the same thing, okay? So what I'm getting at is this approach algebraically for the quadratics, this does not apply, okay? This is not a good way to try to solve a quadratic equation or quadratic inequality, okay? All right, so at this point, you're going to pause the video. I want you to go to practice 1, and you have some inequalities or intervals that you're trying to match as solutions to different inequalities given the graph of the function, okay? So pause the video, try to work through it yourself, and then come back, check your work with mine. All right, so now hopefully you have a little bit of a conceptual understanding of what it means to solve an inequality from a graphical standpoint. So when we're solving quadratic inequalities, we are going to perform a sign analysis on the function that corresponds to the inequality, okay? So that's what this example is all about. Notice I have the inequality x minus 2, that quantity multiplied by x plus 1, and I want that to be greater than 0. And understand, presenting this in factored form, but this is no different than if I were to multiply that out, I'd have x squared minus x minus 2 is greater than 0, which is just proof that this is in fact a quadratic inequality, okay? So if we want to solve this using a sign analysis, the first thing we're going to do is consider the left side of the inequality as a function. So I'm going to say that I'm considering f of x to be x minus 2 times x plus 1. You definitely want to use the factored form of the quadratic if possible, okay? Once you consider it as a function, you're going to find the zeros of the function. To find zeros, you simply set f of x equal to 0 and solve for x on each of those. So I end up with x equals 2 as well as x equals negative 1, okay? Once I have the zeros of the function, I'm going to place them on a number line. I'm going to draw out a horizontal number line that represents the x-axis, okay? And I will put both of those values of x, I'll place points there, okay? And understand what those points represent for the graph of f of x. They are where the graph is crossing the x-axis, okay? They're where the graph is crossing the x-axis, okay? Once we're here, we need to notice how the number line has been divided into 3 intervals, okay? We want to determine if each interval makes f negative or positive by evaluating f at any number within the interval, okay? So the first interval would be the interval from negative infinity to negative 1, okay? I'm going to pick a number somewhere in that interval. So you notice I'm choosing to evaluate the function at negative 2. I chose negative 2 just because it's one of the easier numbers in that interval to evaluate with, okay? So if you plug negative 2 into f, you're going to get a result of 4, okay? And what I care about is that that result is a positive value, okay? 4 is positive, right? So on my number line, in the interval from negative infinity to negative 1, I'm going to put a positive sign there, okay? I do the same thing for the second interval. Now the second interval is in the middle from negative 1 to 2. okay? So I'll pick a number somewhere within that interval. Notice I'm choosing the value of 0. When I plug 0 into the function, I end up with -2 for my result. And what I'm focusing in on is that result is negative. So back to my number line, I'll put a minus sign in the middle interval, okay? Now I'll repeat the process one more time by choosing a number in the final interval. The final interval is from 2 to infinity, and I've chosen the value of 3 to plug in. F of 3 results in 4. 4 is a positive number, so I'm going to place a plus sign in that interval, okay? Now, understand how the positive and negative signs, how they relate to the graph of the quadratic function, okay? Just based on the signs going plus, minus, plus, I can tell you that the curve for this function is behaving something like this, okay? Notice when we are between -1 and 2 in that middle interval, the fact that the interval was negative tells me that in that interval, the parabola is below the x-axis. But then in the other two intervals, we'd have to be above the x-axis where my y's are positive. Okay? All right, so now I'm pretty much done. I just need to use the sign analysis, the picture that I've drawn here, to reason out when is f of x greater than 0. Now, greater than 0 implies positive values, right? Well, the positive values are in this interval and this interval, which would be from -infinity to -1, as well as from 2 to infinity. So I could write my solution in interval notation like this, or you could also write an inequality. I'll leave that up to you. Okay, let's do one more example. All right, so here the function starts in its expanded form. X squared minus 4x plus 3 is less than or equal to 0. Let's solve that using a sign analysis. So I'll begin much the same way as the previous problem. I will take the left side of the inequality and I'll treat it like a function. And then I'm going to find the zeros of that function. So I'm going to set f of x equal to 0. And I'm going to solve for x here by factoring. X ends up being 3 and 1. I will then draw out a horizontal number line to represent the x-axis, and I will place a point on the x-axis at both 3 and 1. These are the 2 points where the corresponding parabola would cross the x-axis. Okay, so now we have divided the number line into 3 intervals again. I will test a number for x out of each interval. Okay, so in the first interval, which is from -infinity to 1, I'm testing the value of 0. Okay, f of 0, if I plug 0 in for x into the function, I get 3 for y, which is a positive number, right? That's positive, so in this interval, I'll put a plus sign. Okay. In the middle interval, I'm testing 2 for x. F of 2 is -1, which is, of course, a negative number. So in the middle interval, I'm putting a negative sign. And then in the final interval from 3 to infinity, I'm going to test an x value of 4. F of 4 ends up equaling 3, which is also a positive number. So you can see the sign analysis for this example turns out to be very similar to the previous, right? It's plus, minus, plus, which means the parabola is once again, it's behaving in this manner. It's opening up, okay? All right, now really the one difference in this example is I have the direction of the inequality symbol changed, okay? Now notice we're trying to solve when is f of x less than or equal to 0, okay? Well, less than 0 implies negatives, okay, which is right here in the middle interval, and then equal to 0 implies the zeros themselves. So basically my solution would be anything from -1 to +3, okay? And I'm including -1 and +3 this time. So I could write the interval as so, or I could come up with an inequality. Okay. All right. So now is your turn. You're going to pause the video. You're going to try practice 2 as well. Hopefully that will help you gauge your understanding, and then come back and check your work with mine.